All right, this problem says the regular hexagonal pyramid shown below has a height of 16 and an in radius of 5.2 and a base with a length of 6. What is the surface area of the pyramid? Round your answer to the nearest whole number. Okay, so we've got first of all a hexagon that we have to account for. So let's go ahead and start there. So the hexagon is the shape here. Let's see if I can do a slightly better job with that. It doesn't really have to be perfect. In fact, what I can do is just select this. And we'll make that a little bit larger for us. And what we really need off of it, I can erase this so that there's less confusing information. What I will do here is make triangles because that's going to be a really important piece to work off of. Because what we're essentially going to do is find the area of, say, that triangle. And one important piece of information that they give us is that the in radius, is the in radius. Which is that length. Okay, that's the in radius. And they give that to us as 5.2. Now, this is the in radius. What they don't give us, and we don't need it, is what's called the circumradius. Okay, so the in radius is important to us because it's going to actually be the height of our green triangle. The base of the green triangle, well, let's just add 6. So that's the base. And so the first part, and why don't we do the work over in this corner, is the area of that green triangle is base times height over 2 or 1/2 base times height, whichever you prefer. So the base is 6 and the height is 5.2. Then we divide that by 2. And if I use my calculator here, which I don't think you're gonna be able to see. But it's okay because it's just 6 times 5.2 divided by 2. So I'm getting 15.6. So then the area of the hexagon, or the textbook uses the area of the polygon. It is all, it's fine either way. There's 6 triangles like the green triangle, and that's by 15.6. So 6 times 15.6 is 93.6. Okay, so that takes care of part of what we need to accomplish. All right, now, and this one's a little harder for me to copy, although I think I know how I can do that. Yeah, it's not going to be too bad. So it's this. This is what I need. Let me copy it, and then let me paste it here. Paste it over here. All right, so there's quite a bit actually to consider. So that end radius again is going to be really important for us. And it goes from here to here. Okay, so that is 5.2. Okay, so in fact, let me see. It might be worth seeing that that's the same as it would be from here to here. Yeah. Okay. And why? So that's also 5.2. Maybe like clear blue. Okay, so why do we need that? It's because there's another piece that we need. No, we want that one to be blue. There's another piece that we need. Come on. Which is from here to here. I'm going to color that red. Okay. So the reason we need that one is because this one here is going to be the altitude or the height. And you're saying the height of what? Well, it's the height of, let me see if I can make it pink here. It's the height of this triangle here. And there's 6 of these triangles. So if I can figure out the area of that like pink triangle, and then I just need to multiply it by 6. But in order to get the height, in order to get the area of the pink triangle, I need that height. Fortunately, I already have the base, which is 6, because it's the same base as this one. Base. Let me see if I can draw that a little better. Maybe on the other side. So that's my base. Okay. And base times height is going to give me the area of that pink triangle. But I need to use Pythagorean theorem because it turns out that this is a right triangle right there. Now it sits on the inside, so it's probably not the most obvious thing, but and I guess I can color that triangle, and I don't know if that's gonna overly complicate things. But there's another triangle. There's another triangle kind of in here. Okay. And that triangle, it turns out we can use Pythagorean theorem because it is let's see, a squared plus b squared equals c squared. The a is a 12. The b is a 5.2. And I'm going to color it in red. That's the c squared, which is actually this here. Okay, so there's a lot going on in there. So that leaves me with, well, I'm going to take the square root of both sides. So I'm left with c equals the square root of, and I might as well figure that out. That's going to be 144. And then 5.2 squared is 27.04. And then, so then if I add those, so it's 144 plus 27.04 is 171.04. And so the square root of that, 171.04, if I take the square root of that, it's 13.07. So this is 13.07. Now, and I'm going to do it way over here, the area of my triangle and this is my pink triangle, is base times height over 2. So 6 times 13.07 divided by 2, 39.21. 39.21. We're getting there. Now the textbook is getting 39.24. And so I'm just going to use a 2-4 just so that I'm not sure that's going to make a big difference in the end, because they do want us to round off to a whole number. So it may or may not make a difference. I need to multiply that. So the area around this pyramid is, there's 6 of them times 39.24. Let me do that. Again, we're getting there. 6 times 39.24. That's 235.44. So 235.44, and then the inside is this computation 93.6. And so it's 93.6. And I'm getting 329. As the final answer. Now, I'm just curious whether that would have made a big difference. So let's try it. 39.21 times 6 plus 93.6, 328. If I'd have left the 1 here, $328.86. You get 328.86, which rounds off to 329. So this is indeed the answer, even with slightly different rounding off. Challenging problem, lots of parts, but that's how you do it.